let's talk about a couple of definitions here. We have something called coordination number, or CN number, and this is simply the number of ligands bonded to the metal. So here the number is 6. There's 6 ligands. Typically, the numbers will range for these coordination complexes to 2 to 12, with 6 being the most common. So here is some notation. If you see this picture, you should be able to write a notation for it. And within a bracket, you would write cobalt, and then you have your NH3, 6 of them. So you put that in a bracket and indicate that there's 6 NH3 groups. Then you have this overall bracket here with a charge up above. And so over here, we have this little bracket plus 3. That means that this whole coordination complex has a charge of plus 3. Because it has a positive charge, sometimes coordination complexes are associated with counterions. So you might see 3 chloride minus 1 ions around to counter that charge. And if you did, you would see the 3 chlorides on the outside of the bracket. So things inside of the bracket are actually coordinated to the metal. Things outside the bracket are counterions. And so that would be how you would translate that particular notation. All right, so we're back to geometry again. As I said, everything you learn in this course we're going to use again. So if you're forgetting some material from units 1 and 2, this would be a good time to review those. So if we have this coordination number of 6 things around, what kind of geometry are we going to have? All right, 10 seconds. Yep, so we have octahedral geometry. And here is an example of our octahedral geometry. So let's just quickly run through the rest of these. You can yell out the answers, either looking at your handout or not looking at your handout. The next one over here, what is it? Right, trigonal bipyramidal. For a CN number of 5, we have another option shown over here. What's that one called? Square pyramidal. For CN numbers of 4, there are 2 things that you'll commonly see. What's the first one called? Square planar. The second one? Tetrahedral. For CN number of 3, what's that geometry called? Trigonal planar. And CN of 2, only one option, linear. All right, so let's just review the angles as well. Those are not in your handouts, but you can yell those out as well. So what angle do we have in an octahedral system? 90. There are 2 angles involved if we have trigonal bipyramidal. What's the angle from the axial to the equatorial? And what's the angle from one equatorial atom to another equatorial atom? So we have 90 and 120. What about in our square pyramidal system? What are the angles here? 90. What about square planar? 90. Tetrahedral? Let's try that again with more enthusiasm. Awesome, 109.5. Trigonal planar, 120, and finally linear, 180. So I'll put those 2 up. Right. So we're going to use this information again in this unit, and of course it'll be on the final when we're talking about Lewis structures and hybridization and other things as well. So this comes back in several times. Vesper theory, you have this several times.